So let's do this one. It says, if 3q equals r, what is the value of q plus r over q? Now, let me ask you a rhetorical question, okay? Does this question say, what is the value of q? Does this question say, what is the value of r? No. Because it's asking you for the value of q plus r over q, this question is essentially asking you, hey, what's the relationship between q and r? Now, we know this, 3q equals r. So let's make up a number. Let's say q is 2. Where did I get 2 from? I made it up. If q is 2, what's the value of r? 6, right? 3 times 2 is 6. So now let's go over to the question, and let's plug in our values for q and r. Q is 2, r is 6, right? 2 plus 6 is 8. 8 divided by 2 is 4. And that's the answer, 4. Now, wait a minute. I hear some of you saying, wait a minute, that can't happen every time, right? What if q is 3? What would be the value of r? R would be 9, right? 3 times 3 is 9. So now let's do it again. What's the value of q plus r over q? What do we get? 3 plus 9 is 12. 12 over 3 is 4. No. Are we going to get 4 every time? Unbelievable. What if I made q 100, right? What would be the value of r? R would be 300. And what's the value of q plus r over q? 100 plus 300 is 400. Divided by 100 is 4. We're always going to get 4. So this is a great example of a question asking you about the relationship between values or variables. Let's keep going. This question says, which of the following is an equation of the polynomial graphed in the xy plane above? So we have a polynomial here on the left. We have a graph, right? And in the answer choices, we have 4 possible equations. So we need to figure out which equation represents the graph, right? So what I'm going to do is I'm going to pick a number from the graph. Look, here we have a very easy point, the y-intercept. What is the y-intercept? The y-intercept is 0, 1. Our x value is 0, our y value is 1. So now I'm just going to plug these into the answer choices and see what I get. Now, our y value is 1, so I can replace this y value with 1, right? And our x's are 0. Now, what is 0 to the 3rd power, right? It's 0. What's 0 to the 2nd power? It's 0, right? So basically what's going to happen here? All these x values are just going to disappear. They're all going to become zeros, right? Oh, and look, +1. So I'm getting a true statement here. I'm being told that when x is 0, y is 1. Yes, that's what I'm looking for. So maybe the answer is A. Maybe we should just circle A and move on. Like, it worked. But wait a minute. Let's check the other answer choices. Let's check answer choice. Oops, sorry, I'm gonna clean up the screen a little. Let's check answer choice B. My x's are going to disappear, and I'm going to be left with y equals 1. That also works. So maybe it's B. If we check answer choice C, we're also going to get y equals 1. So maybe, oh no, maybe it's answer choice C. But wait a sec. If I check answer choice D, right, my x's disappear, and I'm left with y equals -1. That's not true. Okay, at least I can eliminate answer choice D, right? So this is why you don't pick 0 and 1. This is why I recommend you use numbers like 2, 3, 5, 10, and 100, because look at what happened. 3 answer choices remain, and I was only able to eliminate 1. So what should we do? Should we just guess? No, we should pick another point on the graph. Look, we have the x-intercept. Now, what is this x-intercept? It is the point -1, 0. Now, in this case, our x value is -1, our y value is 0. Now, before we plug these into the answer choices, I just want to review something very quickly. What happens if I bring -1 to the 3rd power? Right? It stays -1. But what happens if I bring -1 to the 2nd power? It becomes +1. And if I have -1 to the 1st power, right, it just stays as -1. So let's keep that in mind when we check out these answer choices. I need some more space, so I'm just going to delete this. All right. Now, here I have x to the 3rd power. If I plug in -1, right, that is going to give me -1. Okay. Now I have plus x squared. Now that's going to be +1. Now I have minus x. Now you have to be careful here because it's minus, but our x value is -1. And then we have our constant here, +1. So I'm just going to tack that on, +1. So now let's evaluate this. -1 plus 1 is 0. But minus -1, right, is going to become plus. So +1 plus 1, that's going to give us a y value of 2. Now, is that what we were looking for? No. We were looking for a y value of 0. So I can now eliminate answer choice A. Good. Good. Let's switch to a different color and let's try answer choice B. Switch to a different color and let's try B. So B is going to give us y equals. Now, let's see. Let's be careful here. We have x to the 3rd power, which is going to be -1. Now we have minus x squared. X squared is +1, but we're subtracting +1. Then we have our plus x, which is going to be plus -1, right? Which is -1, right? And then we have our constant, +1. So let's just add our constant. Now, if you add these together, -1 minus 1 plus -1 plus 1 gives us a y value of -2. And that's not what we're looking for. So we can eliminate B, answer choice B. So by process of elimination, I know the answer has to be C. But we can try it. We can check it just in case, right? So let's do C. X to the third power, right? First, we're going to do our x to the third power, which is just -1. Now we have plus x squared, which is going to be +1, like plus +1, right? Now we have plus x. Now we said our x value is -1, right? And then we have our constant 1, +1, so let's just plug that in. And look at what we get here. Look at what we get here. -1 plus 1 is 0. Plus -1 plus 1 is 0. So we got what we are looking for. The answer has to be C. Good work. Yeah. All right. Now, at this point, after 3 problems, you should have a good sense of how to employ this strategy. So at this point, pause the video, try this question on your own, and see if you can come up with the right answer. All right, let's do it together. A catering director is planning the seating arrangement for a wedding. Each triangular table can seat 6 guests. The figure above shows the first 3 possible configurations of tables and the maximum number of seats in each arrangement. If the number of seats in each successive arrangement is increased by 2 over the preceding arrangement, which of the following represents the maximum number of seats around X tables? Now, I see variables in my answer choices. I see variables in the question, so I can make up numbers here. Now, the question says, which of the following represents the maximum number of seats? That means that these answer choices represent seats. And then they tell me X tables, X number of tables. So that means that X is the number of tables. So let's go to the first configuration. What do I have here? Well, I have 1 table, so that's X, and I have 6 seats. That's how many seats there are. So I am looking for 6, right? So if I plug an X value of 1 into each answer choice, I'm looking for the answer choice to be 6. Now look at answer choice A. Oh my gosh, 6 times 1 is 6, right? So the answer must be A, right? Let's circle A and move on. No, because look at answer choice B. If I plug a value of 1 into answer choice B, we also get 6. So it could be either A or B. But let's check the rest. If we plug into C, we get 7. And if we plug into D, we get 0. So at the very least, I can eliminate C and D. But this is why you never pick, or you try not to pick 0 and 1, right? You want to pick different values. So let's take a look at the second configuration. In the second configuration, we have an X value of 2, because that's how many tables there are. And how many seats are there? There are 8. So I want to plug an X value of 2, and I want to get out a value of 8. So I'm just going to clean up the answer choices here. We only have to check A and B. And if we plug 2 in to A, we get 12. And if we plug 2 into B, we get 8. I can safely eliminate answer choice A, which leaves me with answer choice B. That's it. So, how did you guys do? Was that easy? Was that difficult? Is the strategy clear? That's the end of the lesson for now. We'll do some more practice problems on this later to reinforce. But if you have any questions, don't hesitate to reach out.